Now, if we talk about refraction, that is the bending of light. So refraction is a detailed concept. And from the first chapter, you have some idea that we have to change medium for refraction, right? In the previous, we are using water. So we use two different depth of water, that is the deep water and shallow water. So when you are using the same medium, so you can increase and decrease the depth of both sides. So that will also change the thickness. But if you are using two different medium, like if we pass light from air into glass, so then your medium will definitely change. Because in light, we can easily perform experiment everywhere. But for water, you have to contain water in some container. So that's why we are not able to perform with water everywhere, just like the light. So the first concept that is related to the refraction of light is the change in speed. The change in speed of light.
Change in wavelength.
Yes, as it travels from one medium to another. And secondly, light ray bends if it enters the medium at angle from the normal. So always remember the normal ray. Normal ray is very important to identify the angle. And let's suppose if we consider one example of different medium for light ray. Let's suppose if we are using a glass medium. So let's suppose this is the one side of the glass and this is the other side of the glass. So in center we are using glass, and the upper and the lower side shows you this is your atmosphere, air medium, and this is also our atmosphere which contains air. So basically light is going to travel from a rare medium or to dense medium. Basically we call this air as rare medium, and this will call a dense medium, right? So it is not compulsory we use every time air and glass. It depends upon the material. Let's suppose we use water with air. So water will be dense, air will be rare. And let's suppose if light ray enter from the air into the glass medium. So we choose any random angle again, and we have to make a normal. So this is our normal. And when light ray enters into the glass, so definitely angle will be different. Or if we just slightly increase this angle to make it clear. Okay, so basically in this we consider the angle of incidence. This will be your angle of incidence and this is angle of refraction. Now we are talking about bending, refraction. We are not talking about reflection. So it is not compulsory that both angle will be same. And you can easily identify that your angle of incidence is greater than angle of refraction. And when light again enters the rare medium from the glass medium, so if we draw a normal line, so this is our normal line again. So the final picture of the refracted ray will be like this. So now you can identify one more thing, that if we consider the second part, so this is your emergent ray. So this is emergent ray. This is refracted ray. And the first one is incident ray. So this is the ray diagram for your complete refraction when light enters from rare medium to dense and then dense to rare medium. And what happens if light travels straight from rare to dense medium? If light travels straight from rare to dense medium, so what will happen? Is there any refraction in that or not?
You mean like the normal, like the
Yes,
incident?
in the direction of normal. So if
Then
you
there's
can,
no change. It goes
yes.
extra.
So when light enters straight into the medium, so there will be no change. So this is a straight line. So straight line will always move in a straight direction without any bending. So this is the concept. And one more thing that you notice from the diagram, that when we are moving from, so when we are moving from rare to dense medium, like the first case, so in first case you feel that your angle of incidence is greater than angle of refraction, right? So this is our first part, rare to dense medium. So when we are moving from rare to dense medium, so angle of incidence is greater than angle of refraction. And one more important point, that light bends towards normal. Because when you got ray diagram in the paper, so you have to complete diagram sometime, so you need to know about that in which direction we have to make the line. So this is your indication that you can draw the line moving towards the normal, right? If we extend this line straight, so originally this line is moving in this direction, so we just bend towards the normal, so
Wait,
that's
so
why
I have a
your,
question.
yes.
Shouldn't the emergent ray be in the same direction as the incident ray,
Basically
like
you will get,
the same angle?
it will not completely, it depends upon the situation that what type of medium we are using. So it will almost equal to the angle of incidence, but there is no specific rule, or there is no specific idea that we have
Like
to
that.
make. Basically, yes. So it depends upon the bending materials that we are using in between. If we are using glass, so if we are using water, or if we are using any other material, so then it depends upon the direction and the thickness of the medium. So it is not compulsory, and there is no like specific rule to mark that angle. So it is not compulsory that always it will be equal, right? And they will never ask
Okay.
like that, because it depends upon the thickness. Because in glass, there are variety of glasses, right? If we are using a very thick glass, so definitely it will bend with greater angle. And if we are using very light glass with low polarization material, so it will bend with different angle. Yes, but you have to compare angle from one medium to another. Just like from rare to dense, we are comparing that angle of incidence is greater than refraction, and light bends toward normal, and your angle is actually decrease. So your angle actually decreases into dense medium, and further your speed will also decrease. And if we consider the final situation, this one. So in this situation, if we individually consider this situation, so light is moving from glass to a rare medium. So when we are moving from dense to rare medium, so from dense to rare medium, you have to mention all the values with opposite concept. That angle of, if we consider this one as angle of incidence, let's suppose if we ignore the previous air medium, if we consider this one as new angle, and if you compare with the angle of emergent ray, so you feel that your initial angle is less than the final angle. So basically, when light ray moves from rare to, sorry, from dense to rare medium, so your angle actually increases this time. So angle will increase, speed will also increase, wavelength decrease, and wavelength increase, and light bends away from normal. So these are the points related to the refraction, right? Any confusion?
No, sir.
Okay. And one
Yes,
more
sir.
thing for refraction that is related to law of refraction. Just like the law of reflection, we also have law of refraction. So one postulate remains the same, that is related to the rays. So all rays again lie in the same plane. And secondly, if we consider the next postulate, so next postulate is very important because this postulate will give you a complete new concept, and that concept is the ratio of sine of angle of incidence to the sine of angle of refraction is constant and equals to the refractive index. And according to this statement, there is a concept of refractive index. And refractive index actually tells you about the thickness of the medium or the ratio from which it bends the light. So refractive index can be written as the symbol we use for refractive index is a small n, and n will be equals to sine angle of incidence divided by sine angle of refraction. So this is known as refractive index. And always remember one more point related to this refractive index.
Speed of vacuum over speed in vacuum
Yes,
over
we can
a
also calculate, yes. But one more important thing, that if we talk about the value of the angle, so always place larger angle in numerator. So if you again use this concept with the previous diagram, so let's suppose if you apply that refractive index on the first situation when light is moving from rare to dense. So we know that angle of incidence is greater, right? So we place angle of incidence in a numerator, right? And if you consider the second situation, let's suppose in some situation they ask you to find out the refractive index and light is moving from glass to air medium. So definitely in air medium, your angle is greater, right? And this angle will be short. Let's suppose if we consider this one as incident and this one as refracted angle. So you can see now refraction is greater than incidence. So in this scenario, we have to place a refracted angle in numerator and incident angle in denominator. Like if we want to write the formula, so this will be equals to sine r over sine I for this situation. And if we take the reference from the first situation, so we use the normal formula sine I over sine r. So always use greater angle in numerator, because most of the time when we are solving the problem or solving the question, so we use the same formula sine I over sine r. So we forgot to choose the greater angle in numerator. So this is the concept. And in most of the question, you find the same angle with by using this formula. So then you will get this concept that you are getting different answer, but in answer scheme, the answer is different. So the only important point is this, that we have to place always larger angle in numerator. And secondly, sometimes the speed of light is given in the question and they ask you to find out refractive index. So when speed of light is given, so what you need to do, you have to use the formula in different method. So your n will be equals to speed of light in vacuum divided by the speed of light in the medium. Right? So if speed of light is given in the question, so we use this formula. And if speed of light is not given, angle is given, so we use the first formula. Right? So this is the concept of refraction and refractive index related to reflection.